All right, for 1B notes, we need to graph from all the different forms. So we have slope-intercept, like number 19 here. So we need to get it. So if you see a graph, or y is solved for, y equals, we're looking for the slope and the y-intercept. That's going to be the easiest way to graph this. So this is the y-intercept, and this is the slope. So the y-intercept is going to give you a coordinate, 5. That's going to go along the y-axis to 5. And from there, we're going to use the slope 6 over 5. We're going to go up 6 and right 5. Well, if I go up 6, that's going to be off the graph. So instead of up 6, I can also go down 6, and instead of right 5, we're going to go left 5. So down 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And in this case, I can only graph, or only have 2 coordinates. Oh, that's too big. So I can only have those 2 points. Usually I like to have more than 2 points. 2 points is all you really need to graph a line. Looking at number 22. I am going to get this into slope-intercept form. You can find the x and y intercepts. I don't think that's as useful as getting into slope-intercept form. So the slope-intercept form is I'm going to solve for y. I'm going to move the x term. So let's subtract 3x. I'm going to subtract negative 3x and then minus 2. I'm going to divide by 2 to get the y by itself. So it's going to be y equals negative 3 over 2x minus 1. Now to graph this, I have y-intercept of negative 1. I'm going to go on the y-axis to negative 1. Then I'm going to use the slope down 3 from there, down 1, 2, 3, and to the right 1, 2. I can keep going down 1, 2, 3. I'm off the graph, barely, and then to the right 2. Otherwise, instead of down 3 and right 2, I can go up 3 and left 2. And it will be in that same path, up 3, left 2. The more points you have, the better your graph is going to look, the straighter your line is going to be. So 22, let's do 23. I guess we'll work that one out. Another one in standard form. So to get from standard form to slope-intercept form, I'm going to first evaluate. I need to get the y by itself. I have a term that I need to move, so I'm going to subtract 7x. And then I'm going to divide by 2. I have my y-intercept of negative 4. I'm going to go, instead of going down 7, since that's off the graph, and to the right 2, I'm going to go up 7 and left 2. So up 7, 1, 2, 3, 4, 5, 6, 7, and left 2. And there are my 2 points. That's all I really truly need. And there's my graph. So there's slope-intercept and standard form. And then we're also going to do point-slope form. So graph an equation from point-slope form. Remember, we have a coordinate that we're going to get and the slope from this. And once you have a coordinate and a slope, you can draw the graph. Remember, your point-slope form is y minus y1. The slope times x minus x1. Things that we need in here are there's our x and y and your slope. So in the equation, this is really truly going to be a y minus negative 4. So my y value is negative 4. And then our slope is negative 3, so that we can put that in. And our x value is opposite. A lot of times I'll tell you it's just opposite, is negative 2. So now I'm going to go to the graph and go left 2, down 4, put a point. Now I'm going to use that slope, put it represented as a fraction, so down 3 and right 1. Now that is off the graph, so I want to also, I can go up 3 and left 1. So up 3, left 1. Up 3, left 1. Up 3, left 1. And there, if we draw a line through, that is our graph that will represent that equation. Let's try this again. So what point do we have? We have a plus here, so that's minus and negative. So we have our coordinate of positive 2, negative 3. And our slope is -2. So I'm going to plot the point 2, -3. And then I'm going to use the slope -2/1. So down 2, right 1. All you need is 2 points, and that would be good enough. You can move the negative to the denominator. That'd be up 2, left 1. And you can continue with that pattern as long as you want. You see all those points are a nice straight line. Gives us a good idea of how to draw that straight line. And that is